afternoon, everyone. Welcome you all to BD Kulkarni Endowment Lecture. Today's speaker is Dr. Ajit Sapre. I think most of us have seen him as the RC chair in NCL and have heard a little bit, but today we're going to hear him for a longer period of time. So before we start the talk, I would request Ashish to welcome our guest with a special orchid.
You have to. You don't have choice.
They gave me a plant yesterday.
And a shawl.
And you have to do this as well.
This will be after the talk. Yeah. I'll request Ashish to say a few words about the lecture series and also introduce our speaker today.
Very good afternoon. Real pleasure and privilege for the lecture to you as well as the speaker for today's lecture. I think maybe there are only a few people in the auditorium who do not know Dr. B.D. Kulkarni. So BDK as we used to call him. For a formal introduction, I will just read out a few things from the flyer in NCL. He was truly, a chemical engineer in every way that you can imagine. Somebody who designed plants, scaled up technologies, at the same time did a whole lot of fellows of all the 6 academies of India, TWAS fellow, and also the J.C. Bose fellow. I have very, very fond memories of BD, and I can tell you if there are few people in this laboratory who I respected the most and had great relationship with, it was BD. And I cannot tell you how full of sorrow I was when I heard at 2 a.m. in the morning that night about his very sad demise. He was truly a legend, a real guru, a real mentor, philosopher, guide, at least to me. I have seen him stand up and give impromptu talks on nonlinear dynamics with not a single paper, not a single slide in his hand, spoke for 1.5 hours, non-stop. Somebody, you can do it only if you have such great clarity of thought in your mind. He would go on starting from simple reaction kinetics into n-dimensional space and talk about very complex reaction networks, an absolute phenomena. He was also somebody I knew who many decades ago implemented in India on a real large-scale commercial polyethylene reactor a data-driven modeling algorithm that would real-time control the polyethylene, not just the production, but also the quality of polyethylene that was made. And at least in India, Ajit, this was a very long time ago when data-driven modeling was not even known to people. And he had a soft sensor deployed in the Hazira polyethylene plant of Reliance. And I don't know whether it is still active, but in those days, this is what he managed to do. So, in terms of his scholarship, an exceptional scientist, but at the same time like me. And I remember at least 2 directors would always say that all the difficult problems, which are almost always related to people, all the difficult problems, they would send them to BD. And they would do all the simple stuff. And BD, with his very gentle manner, would resolve all of those very, very complex problems. There are people in this room who know BD much more than I do. We have Dr. Tambe here. We have others. And I am very happy that some of them have come together to create this BDK Endowment Lecture. So it's really as I said, a very matter of great pride and privilege for me to tell you about BDK and his lecture. Uh, as the speaker for today's lecture, we have another exceptional scientist with us. As Sarika said, we know him as the chairman of our previous RC, but I have had the privilege to know him close quarters for at least 3 years when I was in Reliance and Ajit was my boss. Uh, Another spectacular career, again a chemical engineer from at that time UDCT, went to do his PhD at the University of Delaware, the same alma mater as I, and I joined in 1988 at Delaware, and he joined Ajit at 1976. But so that was, at least 10 years gap between us. And I can tell you that when I was a graduate student, the name Ajit Sapre was very much in the department. Okay, a stellar student. Um, for 10 years to have that reputation in the department is no joke. In fact, I remember seeing his thesis as well, which was part of the uh, graduate student office in Delaware. So I've known him for a very long time, but got to know him much more closely when I joined Reliance and uh, joined his team. Uh, you know, is there any field of chemical engineering that Ajit has not touched? I will find it difficult to say. He worked, of course, in the oil and refining industry for a very long time, was at ExxonMobil for many decades, and rose all the way to the top, handled many different portfolios, showed his leadership in many different areas, whether it was manufacturing or business or corporate strategy and policy. He excelled in every single thing. Uh, he's a great storyteller. You should listen to him uh, recounting his experiences, whether it was in ExxonMobil or in Reliance. It's fascinating to see how many things he has done. And I find it normally difficult to say one person in 40 years of life could have done so many things. Whether it was the first ever hydrogen car built many decades ago, um, to creating the first models of global climate change. Uh, he has done everything and everything in between, from putting up large plants, designing large plants, very complex refining chemistries, and then coming to Reliance and setting up a world-class R&D center, employing hundreds of exceptional scientists and doing work that in those days I don't even know how he managed to do all of that. Algae to oil, for example, is something that you read today, right? Those of you who read chemical and engineering news would have seen in the last, I think, 2 or 3 issues behind, there was a big article on algae to oil, and people now talking about algae to oil. Ajit did it 20 or 15 years ago. Uh, at one point of time, the Reliance algae to oil program was the largest program anywhere in the world. And from there, whether it is waste plastic pyrolysis, or making biodegradable polymers, um, and just a long list of technologies that he has been instrumental in developing, and not just remaining in the lab, but taking it all the way to commercialization. So we have today, to celebrate an exceptional chemical engineer, we have an exceptional speaker today to talk to us about how to set up world-class industrial R&D facilities in India, and these are his totally personal reflections. So with that, Ajit, I invite you to deliver the talk. Platform is yours.
Don't make it too complicated. I'm a simple guy. Yeah, thank you, Ashish, for such kind remarks. I even don't remember what exactly I did myself. So, anyway, this is like my personal story of coming to India. I was in ICT yesterday, and I'll talk about it a little later. But I was hired by Reliance about 18 years almost, 18 years ago. Nobody believes that I could stay in India for 18 years. I remember the bets taken whether I would last for 3 months or 6 months. I shouldn't touch this. I stand right here, don't worry. This far enough? Oh, good. But then I had to still speak into this. No? So no worries, no worries, no worries. So anyway, people who took bets, then they revised it 3 years, 5 years, and then they got tired and they said, oh, let's break up this department so that way we don't see his face and don't get bothered every day. That doesn't matter. I mean, most people in India don't know what R is, what D is, and what technology is. That's my frank opinion. That includes CSR once in a while. So I'll tell you what exactly I thought I was hired to do. Now, to be blunt with you, Dr. Michelle was responsible for bringing me from the US. And then Mr. Ambani gave me such a fancy story, I couldn't resist. But it wasn't any of that. It was my mother who said, I got to come back, otherwise she won't talk to me. That's why I'm here, okay? So most people lost it and they had to blame my mother, nothing else. So anyway, the way I looked at it was to build an industrial R&D that actually commercializes something. And neither Dr. Mishelkar or or Ambani thought, their model was probably CSIR. Because when I started developing this, I needed billions of dollars, then they got shit scared. But anyway, I'll tell you what we commercialized and what we actually did. So early days I had a lot of power. I could spend money without asking anyone. So I built very fancy lab and a lot of instruments and everything. The whole thing was, my idea was that I'm going to develop some front-end research in Mumbai, but also built all the pilot plants at our refining facilities. Because to me, translational research involves transferring basic science to real engineering and understanding CapEx, OpEx to build real plants. And so that was my whole objective from day one, because that's what I did in my previous life. Although I wasn't in research, I was in research only for 10 years in my career. Then I moved on to all these various jobs, upstream, downstream, chemicals, you name it. Operations, not operations, but technical service. So anyway, so we had built a fairly sophisticated facility by its standard within a year, within 2 years. It took me 1 year to build a building. But we had to think about what are the things we want to do. And see, my model thinking was very different. My model thinking was I need to build a capacity and capability that I can solve any problem. And where I came from, to me, a physicist, biologist, chemist, they're all the same. I needed all of them, mathematicians, you name it. Anybody has some basic understanding, you need to have all these disciplines to do something creative, right? So I had only 3 slides I showed to Mukesh Ambani saying this is one of them. And we had this MCM22 catalyst, and in my mind, after ZSM5, MCM22 was the most important zeolite that they had invented. And so I came to tell Jasra, I who has done it before and who will give a guarantee. And so that requires that how do you move people from having a concern about something to having a confidence about doing something. So these activities, if you commercialize and show that can work, to show that it is something we can build confidence on. It took me a lot longer than I expected, but now a lot of things are happening which I'm really proud of. So anyway, this was something ExxonMobil couldn't do, and we commercialized it, and now it is getting commercialized at the largest plant in the world in Jamnagar. And so, the guarantee that they wanted, because typically the clays are replaced every 3 months. And I said, okay, I'll give you a 10-year guarantee. Now it's been more than 5 years and it hasn't shown any deactivation, so it may last for 20 years. So this is a great success story from having a catalyst to replace a clay that actually took care of all the operating problems and headaches of operators. But more importantly, we did something that somebody else couldn't do. And this multi-layer zeolite catalyst has a lot of other applications as well. And next one, I'll kind of, what happened now? I think I'm a toxic person here or something. No, I'm right here, man. I'm nowhere close to that. Anyway, I'll skip through a lot of the slides very quickly just to show that we are doing something in polyester. So this was about an oxidation catalyst we developed. Has been implemented in many plants. It is the best oxidation catalyst for this particular application for the solid state polymerization chemistry to purify the streams. And it is significantly lower cost and better than what's available in the market. The next one that is commercialized today is this CPVC technology. And again, what we wanted to do was, Lubrizol is the leader in this business. And everybody who makes CPVC today use ultraviolet light. And so we wanted to show that the same chemistry can be done with the LEDs in the conventional light spectrum. So you can manage heat better, it's much cheaper in terms of electricity cost, but more importantly, it produces better quality CPVC. We built a pilot plant, and my objective is very simple. This is a batch operation. So, worst that will happen is I'll take a little longer to finish, or minor problems. So I had a systematic thinking about how am I going to build a capacity and capability to get them to build most complex reactors known to mankind. I'll talk about some of them. So anyway, this one took much longer than I anticipated. I must have built this pilot plant, 10 years ago? Also built a cold flow unit to demonstrate the effect of light. And this is about the time I was getting involved with algae. And I'll talk a little bit about algae in terms of my understanding of photosynthesis, which is perhaps the most critical one. But anyway, assays can't be that complicated. So we figured out finally, and it's getting commercialized. But we're not only making the resin, but we're also making the whole compounding. So except for Astral, who want to make their own compounded material, we can provide to many customers. It's again going to get commercialized as we speak. So I'm quite happy that it's happening. The next one is DPE, that even Ashish got involved to try and get some others. And for the longest time, nobody showed any interest. But all of a sudden, it's getting a lot of traction because there are a lot of downstream customers being lined up. And this is a unique polymer. I think I talked about it before. It's a very high crystalline. The molecules are aligned. And this can be a very good bulletproof material. But there are other applications like you can make a different varieties of ultra-high molecular weight polyethylene grades that don't exist today. You can make wallpapers. You can print even money, like in other countries in Australia. So the counterfeiting could go away. But we are starting with bulletproof waste, which is the most important one. And we actually demonstrated that this plastic multi-layer sheets can stop a bullet. It's better, much stronger than steel, better than Kevlar or any other polyamides. So this is again getting commercialized. But one of the first things we did, and that's in this blue bucket, is that we started replacing all the foreign catalyst and the donors. So we did that for polypropylene. We did that for our own catalyst for PE. So we replaced all the polymer catalysts. So we make about 35 million tons on our own catalyst today. We're also now making a phthalate-free catalyst. Will get commercialized soon. And I did the same thing in refining as well. So where we make the recipes, get them toll manufactured, things of that nature. Since there's a lot of energy around waste and resource utilization, recycling is a very good marketing ploy. How much it helps climate change could be debated, because the polymers compared to oil is like 10%, and of that plastic is some percent, and you go down and figure it out. But still it's important, because otherwise you have garbage and way to at least monetize, but nothing else, you're reducing the net oil input. So it's a good thing to do. But if you think it's going to help climate change, I have my doubts. Okay. So anyway, I'll talk a little bit about that. And minimizing recycle and reuse is good for our own, what I would call sanitation and well-being. So we develop a catalytic system and a reactor system. And our real advantage here is we can take waste as is. You don't need to segregate between plastics and dirt and anything. And just go through this reactor and you can get this oil. You can see the picture on the right-hand side, the catalytic process we have developed versus the thermal process that are many people offering. Certainly our yields are higher, the quality is better, and then you can close the loop by converting this oil into plastics again. And this is getting commercialized at many multiple plants as we speak. Reliance is also very big in getting maybe the first company in India to receive this international sustainability carbon certification. I don't know, this was more than a year ago, so maybe there are others who have gotten it too, but we are the first ones. And we're trying to do this for all our polymer business. So talking about sustainability, I mean, the way to look at it is that you can classify various polymers into either bio-based or fossil-based, and whether they are biodegradable or not degradable in this simple chart. So there are two materials that we worked on. One is PBAT that is getting commercialized, and it's been all approved and everything. That we'll talk about next. And PHA. In my mind, the PHA is better than PLA. I understand somebody's putting a PLA plant, in the near future. So hopefully we'll be successful with PHA, and there are different flavors of PHA, but the one we are working on, hopefully will get commercialized in not too distant future. So this is a PBAT story where we develop our own chemistry and we started demonstrating it. Made enough material to put it in Reliance retail stores as a packaging material, as a bags, as well as net bags. And so certainly it's been accepted by the customers. The Reliance retail is happy with performance. Initially they're buying it from China and trying to seed the market. Now we're trying to build about 60 KTA plants, so that'll be good to supply to the grocery stores, not just in Reliance, but maybe other as well, and could get expanded as the capacity requirement goes up and other applications develop. I'm sure a lot of people are excited about climate change, so I should talk about climate change. Since I've been involved since 1919, I know a little bit about climate is changing, whatever it is, but last year was the warmest ever in the history of mankind. And the most important thing is that Paris Accord gave us 1.5 degrees, which we already exceeded. And French are the only country which has a plan for 4 degrees centigrade by the end of the century. And you should read it. It's very carefully done for every region and what needs to be done on the coastal region versus agriculture region, wine region, this and that. I think India, we need to work on this. Because the countries closer to equator will suffer the most compared to the very north or very south parts of the world. Other important part is really the net energy absorption by the Earth. See, Earth has been in equilibrium about the sun energy coming in and the infrared light going out. So we were in equilibrium till about year 2000. But last 20 years, we are actually, because the albedo or the reflectivity of the Earth has changed, Earth is retaining energy. I think today we're returning at 1.5 watt per meter square, which is significant. It's accelerating, by the way. So we will be warming up much faster, and then some are predicting the AMOC, which is the heartbeat of Earth in terms of the ocean currents, will probably stop between 2035 and 2050, depending upon who you talk to. And if that's current really stops, then we are doomed. Large parts are doomed. But regardless of that, I mean, we're having these terrible downpours and floods, and they will continue. It's because, to me, climate change is actually ocean warming. Ocean much warming much faster, and although Mr. Trump changed the name from Gulf of Mexico to Gulf of America, I don't think it's going to stop my hurricane worries. So this is something we should be prepared for. And so there are many things we can do, and so one of the things we are working on, technologies which could help, and I put them in 4 buckets, and some of them I talked about, so I'll kind of run through very quickly. The one on the left is the multi-zone catalytic cracking, which would require several $1 billion to commercialize. And this is a very high severity FCC unit. And I had done some work on this, putting feed on multiple locations on the riser in 80s, and I had commercialized it at a couple of refineries in the mobile system, because we wanted to increase the octane number. And when I came to India, I told Asit Das, who was my person for refining R&D, to build a pilot plant with multiple location to feed. And the reason was I was quite convinced. What happened at that time was our group also invented ZSM5 and showed to the world that ZSM5 is far more effective way to, as an additive, to change the octane or improve olefin content and things of that nature. So nobody was interested in changing hardware, which is far more expensive. So anyway, one day this will be happening. But regardless, since our pattern got published, many other people have started to think about in this direction. In fact, Chinese have done some work. And not too long ago, S-Oil and Aramco commercialized a similar unit with a different configuration, but same concept in Korea, not too long ago. But they have a downer instead of a riser. One on the left is actually a CO2 concentration technology for dilute flue gas. And a lot of people talk about CO2 refining and all the nonsense about, which is to me, they have not understood economics at all. I'm sure Asit has figured this out, but if you haven't, the cost of concentrating CO2 itself with the total, most fancy amines from fancy companies, about $60 a ton. Some of the startups are talking about $30 a ton. Since somebody told me to give a problem of algae to oil, where CO2 is the most important feedstock, I gave a target of $10 a ton, and we achieved $20 a ton. But anyway, we built a bunch of gasifiers, so we now have pure CO2, so don't need to worry about concentrating. The world would need this, and this is not amine-based. This is purely adsorption, desorption technology. And since the delta temperature difference between regeneration and adsorption is much lower, our costs are much lower, and this actually is much better technology. But nobody's going to do it in the near term in India. The one and two in the middle I'll talk about. And there's all the rage about hydrogen, so I must speak about hydrogen. I've been involved with hydrogen. Oil industry loves hydrogen every time somebody talks about climate change, right? Like he was saying, I built a fuel cell car. It's the same era. We were looking at hydrogen engines and all kinds of hydrogen stuff. Our idea was if somebody wants hydrogen, we'll make it from hydrocarbons, take the CO2 and bury in the ground. We know how to take hydrocarbons, or we can do CO2 sequestration as well. So anyway, the all rage today is about we almost have a free electricity from solar panel, which is not true, but let's assume it is free. And then I can do electrolyzers, and then Asit is deeply involved, I understand, but today we are somewhere between who you talk to between $4 and $7 a kilogram. And there are a lot of pronouncements about $1 or 110 year or whatever, right? I don't know, it's a virtual reality or reality, but you need inventions for that. I mean, there are no inventions that I know of so far. But I've been away for 1 year chasing tigers, so some inventions have happened, please let me know, okay? So to me, it is not a problem of just economies of scale and scope. It's a more fundamental problem. And Europeans want to do it because they got this excess capacity. They don't know what to do with it. So people are. Anyway, somebody's excited about hydrogen, so we said, okay, we'll do hydrogen from biomass. It had nothing with the biomass. I was trying to do it from coal and petroleum coke, and I'll talk about that. So there's a green premium that you have to reduce it to the SMR cost, which is between $1.50 and $2 a kilogram. Now, obviously, our cost depends upon cost of biomass, but that's independent. My target was I should be at the same cost as SMR, and we can do that. Anyway, the problem of burning agriculture does exist in the northern part, and you can solve two problems. A, get rid of the pollution challenges, put some money in farmers' pockets, but more importantly, make a green hydrogen. Obviously, somebody will react to that violently, saying green is hydrogen. There are all kinds of colors of hydrogen. To me, it's immaterial because the renewable hydrogen is what matters. You can give all them whatever color you want to please yourself or confuse somebody. At the end of the day, it's renewable. If it's within the carbon cycle, I'm fine, and that was our idea. But what it was we had a catalyst in my previous company, which was a homogeneous catalyst we would spray on the coal. And that catalyst worked in gasifying, and basically steam gasification at a much milder condition. And we also had some fancy technology called flexi-coking and fluid coking. It was one of the most imaginative engineering ever done in chemical engineering. You should go study it. The whole vacuum tower sits on this reactor itself. But anyway, it's just kind of interesting. Regardless of that, when I came back here, I talked to Asit and say, hey, and this is way before we even built our own thermal gasifiers. This is interesting. Can you heterogenize this catalyst? Because if you heterogenize this catalyst, the problem wasn't the catalysis not working. The problem was recovery of the catalyst and cost of recovery and pots of pans needed to do it. But lo and behold, I had one job where I wanted to make money out of all the R&D investments because I was out of the R&D. And Mobil and Exxon merged, and they gave me a job in saying, go figure out what the hell we got. So I sold about 300 technologies. One of them was this we also by the time had gotten out of the coal business. We were the largest coal miners in the South America, Exxon was. So anyway, some Israeli startup guy was clever enough to do this. He raised some $400 million, built a plant around some electricity company in Boston, and sold it to Chinese for $1 billion or something, made a lot of money. And then he got all excited because Chinese were building a plant. And then he was coming through India and wanted to sell such a gasifier to Reliance, which I said, okay, it's very interesting. Entertained it, but then let him go. But Asit was successful in heterogenizing it, and with whatever little resources we had, we were able to develop this whole technology at various centers in the US and came back and converted our FCC pilot plant to demonstrate we can actually do this. Then the real question to me was, okay, I'm doing it in a pilot plant like 3-story tall, but being a scale-up guy and having designed lots of reactors, I said we got to worry about understanding the fundamentals. And this is really what I call migratory catalysis, which I'll explain in the next slide. But our cost target is somewhere in the range of same as SMR. And the catalyst is doing the work like an FCC unit running between the catalyst and regenerator. And I use air to clean up the catalyst and give that energy of endothermic needed for gasification. So it's a much milder operating conditions. I gasify around, I don't remember, but 650 or something, 700 degrees, not like 1200 where thermal gasifiers are running. So our capex and opex is almost 40% lower. Okay. Now I went to even our ministers and Niti Aayog and saying, hey, there was all this rage about clean coal and coal India, and everybody wanted to put coal gasification. So I was trying to sell them this is a good idea. And they kept on saying, if it's good, why don't you guys do it? Right? It's a typical, who's going to do it first? So this was developed for coal and coke, but then we say let's apply it to biomass because hydrogen is all people excited about. And we make no tar at all. So this is what, this is the chemistry. The idea is the catalyst actually migrates from a catalyst particle to a carbon particle. It gasifies it. And the whole trick is how do you get the catalyst back to the catalyst particle? And that you can do by manipulating operating conditions and the partial pressure of various components. And that's what we accomplished and demonstrated what the mechanism is. So now we are confident we can scale it up. And this is getting commercialized as we speak. The original design when I left was about 1,500 tons per day. But now I think they're thinking about 3,000 tons per day of plant. So all the basic design is done, the work is done. This will get commercialized. So I'm quite excited. This is not only a novel science, a novel reactor design, a novel catalyst, but it's going to get commercialized to show, first time in the world, a green hydrogen from biomass. Okay, I call it green. You may give a different color, I don't care. But it's within the carbon cycle, okay? But that's all great. Today, all hydrogen is produced and consumed at the site where it is generated. Okay? Very few places there are pipelines like in Rotterdam or where there are all kinds of refineries and petrochemical plants. But my friend Sid said, I'm going to do it for trucks. I said, fantastic. We did all kinds of plans. We made lots of spreadsheets. So I think we have to still figure out how to store it and how to transport it. And in my mind, the cost of large scale talking about is somewhere in the range of $2 to $4 a kilogram. So delivered cost of hydrogen is more important. And to me, it needs some inventions. This is not just a problem of scale, or maybe in some selective cases you can build some corridors to do this. But this is not something as a future of energy, at least not from my perspective, since I've been involved in this for a long time. So I found this cartoon. You may get offended, but so be it. It is like you are trying to send a rocket with a bunch of firecrackers. Because the net energy, once you take sunlight, you split water, you bring it, and you again use it as energy, the useful energy is only about 33-34% with today's technology. And you will hear this word invention more often in my talk. Because innovation, a lot of people talk about it, is great. We should do some of it, but not all of it. This is what is more important. And the reason I'm saying this is because I have alternate solution. If I had no alternate solution, I would have been on the hydrogen bandwagon myself, right? But regardless of this, some people want to do it as great, but focus on how to cut the cost of delivered hydrogen by order of magnitude for it to take a scale where it becomes a source of energy for the world, okay? So what are the characteristics of a good energy? And why is the oil business around for 150 years? If you start fundamentally think about it, some of these characteristics are there. It's a high volumetric energy density, it's portable, it's available. I can use it at will, 24/7. And there are only two things in my mind. One is nuclear, and other is what I'm going to talk about, the green oil. And I talked about green oil before, but it's worth mentioning because to me, this is something that is important. So if you think about historically how the world has changed, this is just because of the way markets work. We moved from wood burning to charcoal, to coal, to oil, right? And now gas. And gas has energy density by weight, but not by volume. And where the cost of transport and storage is actually volumetric energy density. And that's where the crude oil has the highest advantage. And when I talk about green oil, it's nothing but crude oil made from today's biomass. So if you think about the only renewable energy that could save the world in my mind is nuclear. Now some may debate is renewable or not, but it is renewable in my head. And I'm a big proponent of both fission and fusion. And fusion is accelerating very fast. And our neighbor is doing much faster job than anybody else in the world, okay? Both in fission and fusion. And I was surprised and flabbergasted. I've been studying nuclear because I know nothing about it for quite some time. There are like 30 or 35, 40 odd designs for all kinds of markets. So Chinese are ready to take care of the world when you need it. But our electricity from nuclear is less than 5%, although a lot more plants have been getting built. I think we're going to be at 35 gigawatt or something, but still it's minuscule compared to our needs. I think France is probably the only country which is at about 70%, I believe. And so I wonder why we are not at 70%, right? So anyway, if you think about our mega cities, they are growing, and they're growing very fast, and we're generating a lot of municipal solid waste. And since I got involved with photosynthesis, I started thinking about what exactly is waste. It's nothing but the sunlight, you know? And it really dawned on me. I'll talk about it in the next slide. But anyway, I can convert any organic material, right? Whether it's a municipal organic content of municipal solid waste, agri waste, human waste, whatever waste, okay, to oil. And that is because how was the oil formed in the Earth's belly in the first place? It's the old dinosaurs and old biomass that got cooked up in the Earth's belly for a long period of time and made, depending on the severity, either oil, coal, or gas. That's simple. So if I can reproduce that process above ground, then I have a chance to do something similar but renewable within the existing carbon cycle. So that was the idea. So we do have a fairly large pilot plant. You've seen the pictures before. This was built for algae. And then we said we start using it for alternative feeds, which are shown here. Municipal solid waste, agri waste, and we've done all of them. And we can make a green oil. And once you have green oil, you can use it for making transportation fuel or ATF today. Or you can burn it to make electricity, right? To me, it's the best battery in the world. Highest volumetric energy density. It will beat any electrical battery anytime for the foreseeable future, okay? So the whole idea was that I'm mimicking what happened to make the oil in the first place in Earth's belly above the ground with today's biomass, it is today's sunlight. And we also use catalysts. There are some thermal processes, and the catalyst actually deoxygenates to make higher calorific value oil, much closer to crude oil. That was the whole idea of using catalyst. You get a little bit of higher yield. And then we made some economics of saying if I were to convert instead to CNG, which is the rage in the world today, what would the economics will look like? Now one could debate whether these capital numbers are accurate, not accurate. Some say, okay, CNG is getting much cheaper, whatever it is, it doesn't matter. Because the way to look at it is that amount of energy in the feed and how much of the energy is recovered in the product. And although CNG has a higher energy content, it is not producing as much as the oil I produce. So we recover almost 70% of the energy in the feed as energy in the product. In bio-CNG, you're making a lot of low-quality fertilizer, the low NPK content, almost 50% of it. And if you build a lot of this plant, then you have to worry about what the hell you're going to do with the fertilizer. And there's a movement somewhere I heard that we should go make organic farming. It may sound good, but we may become Sri Lanka if we try to apply this whole countrywide. So you have to be very careful. So to me, this sounds good. It may work for a few places and where there's government incentives, you can make money. But if you really want to be first in the world, you should convert all that shit to oil. And the reason I want shit is because a guy in UK came with an idea of converting UK shit to aviation fuel. He talked to us a year and a half ago, 2 years ago, and he got really fired up. Okay? And lo and behold, one day, 1 ton of UK shit showed up in Mumbai port without any biological certificate, nothing. And all of a sudden they said, Reliance wants the shit. And I said, we were talking about concept. I'm not ready to do any of this stuff. You know what I mean? So we sent it back. But what I meant was somebody in the UK is actually trying to figure out how to convert human waste to oil. Okay? So I'm not that far off. There are other people thinking about such things. But anyway, I'm thinking more about municipal solid waste, which is a big problem for us. And to me, at a $10 tipping fee in India today, in Goa and Mumbai places, I can make this green oil at $30 a barrel. In the US, where tipping fees are much higher, on average 50, in California 80, at $80 a ton, actually I'm making free money. The cost of oil production is minus $50 a barrel. And the country that imports so much oil, I've been talking up and down, nobody's interested. Right? Nobody's interested. Who has done it and who will give guarantee? These questions come up. And they're very low investment. You're not talking about billions like I like in refining. You're talking about 20 million, 30 million, because they're distributed plants, right? And the oil infrastructure exists today to move oil. You don't need to build new infrastructure for hydrogen. So you can exploit it today. But somehow I'm the only dumbest guy in this whole damn place, to be honest with you. Nobody has ever figured out we should do this, you know. And when somebody says, no, I'm the only fool who says, Maya, we must do it, you know. And especially higher up the food ladder is, I'm convinced I must do it. And that's because I'm always at the bleeding edge and I see value in everything, right? But I do look at things and what could go wrong, because I learned something in my 40 years, that whatever you do in a pilot plant doesn't work at commercial plant. Something goes wrong, and you got to be prepared to figure out what to do and how to do it. And I'll talk, actually I could give an entire lesson on what exactly translational research means. Okay? But anyway, regardless of this, if you think about it, amount of carbon we consume to keep us cool, warm, go from places, on an average basis, is 20 times more than the food we eat. So if you start thinking about it, you know, you take food and you take waste, I'm never going to meet my needs of energy to replace all carbon, right? Then obviously we started thinking about how to make on-demand carbon, and that's where this algae idea came out. Now people are talking about CO2 to make some low-quality cement and things like that, but on a volume and the basis of what we need to solve, if I can convert the CO2 to oil, that would be useful. And that's where we built a big pilot plant, about 60 acres, and tried to de-risk the technology, because Reliance also was investing in some startups. They're all biological companies, so I learned quite a bit about biology and what to do and what not to do. One thing I learned was this biology is great in the laboratory under very controlled reactor conditions. The moment you take them outdoor, all kinds of unknown things happen when you have to live for 365 days a year. So when the biologists came and they're going to do this, I said, you know, forget about all this stuff. Take all these various organisms you got, put them in a damn pot outside and see what survives after some time. That's the best way to do experiment and go figure out, like somebody was telling me, you know, they had this big library of microorganisms. That's great. We built a library, you know, we got some 500 species of algae from all over the country, and then biologists were going crazy in what to do. So I said, don't do any of this nonsense. Just put them all out and see what survives. And lo and behold, we found one that worked very well. It produced a lot of oil. But we de-risk. And there are some challenges, don't get me wrong. When you scale it up, there are some challenges. But if you have a confidence, where I came from, nobody ever questioned that these R&D guys and these technology guys or the engineering guys can't solve the problem. That was your job. If you don't get solved, you get fired, right? And they understood the problems are going to come up. Whereas here we are, you know, we are so used to buying a licensed technology has been commercialized so many times. We just don't understand what it takes to put in a commercial plant and do a translational research, first of a kind. But anyway, the first thing I understood was all this biology is fantastic. And I hired a lot of gene jockeys to modify everything under the sun. And I'll show you some complicated gene modifications. But I walked away with a simple understanding. It's energy to energy. So I need to understand photosynthesis. And I think I drove most of these guys nuts. In fact, he was responsible for building this whole Gagawa facility. You know, he was doing dirt moving and other stuff. But then he came back and said, this is a rough job. I said, don't worry. We have to do some scientific work. So I was the only fool who assembled some 8 big photosynthesis guys, locked them up for 7 days in Phoenix, and sitting there understanding what they said and trying to figure out what is meaningful. That was the hard part, right? When you get all these deep minds, they got deep somewhere, right? I asked a simple question, and they kept on saying, we can't measure these things because the first part of photosynthesis is quantum biology. and the efficiency of splitting water is 99.9% or something, right? But then I started questioning, why is the biology so slow and why is it, then they started talking about Rubisco and all this nonsense about the back. People have been working on it for 1,000 years, can't figure out between oxygen and CO2. I said, look, the photosynthesis is what's giving me energy. The back end is not able to absorb all the energy. That's why all these mechanisms to dissipate the energy. That's why the C3 plants are only 3% and C4 plants are only 5%. So actually I spent some time in Thailand to understand what they're doing to go from C3 plants to C4 plants, like rice and other things. I walked away with an impression, this is too complicated a biology. We got to figure out. I kept on saying, as an engineer, I need to understand rates. I don't care what is measurable, what's not measurable. I know what's coming in. I just want to know what is the energy in the biomass I produce. So we went through about 6 generations of photosynthesis, and I was the only fool pushing these guys very hard. You know that, right? I had to go to Israel. Some physicist told me he knows something. I spent a week with him, got him on the board. He published a paper in Science. He was happy. But that model was just a beginning. So we went through 6 iterations, and my objective was that I not only predict my data, but I predict somebody else's data. And what these lines and dots are data of an Israeli group, which actually did experiment up to 8 sunlights. So they did put some work outside, but they did a lot of work indoor control condition as well. And the lines is our model predictions of their data. So if I have this quality accuracy, then I know what the accuracy of my CapEx, OpEx spend would be. And that is the most important part of any translational research. I need to have an ability to predict CapEx, OpEx within 20%. And this sort of model gives that. But the most important thing that came out, which was unanticipated by any biologist, was that if I cover the pond, my productivity goes up. And it goes up far more than any genetic modification ever done. Okay? Nobody would believe that, right? And this is a COVID time, nobody would do anything. So we were putting tarpaulins on our ponds to show that actually productivity goes up and convince the biologists that engineers are not as foolish as they think. And the hardest part I had in my mind, to have the biologists and engineers to talk to each other. That was an impossible task. Neither one understood each other's language, and I didn't care about anyone's language. I was just trying to make them to work. I mean, you were there in the middle of all this nonsense, right? And they would listen to me, I don't know why, only because they thought I was a boss or something like that. But communication in terms of technical understanding lacked all the time. They would do things because they say, Arey, Ajit is asking, let's do it. You know what I mean? But more importantly part was, how do you scale it up from here? How do you scale it up from here, right? And that's where I failed completely. Because I said, oh, we are building so many solar plants. Why not I do this under the solar panels? It will solve 2 problems. I can use the same land, I can cool the solar panels, improve their efficiency. And the reason I'm doing it is, to me, this is a battery. To you, it may be something else. And I'll explain you why. So if you do, and you get at least 30% productivity if you do it. Our models predict I can go up to 50%. But we could never do it 50% on an annual average basis. But 30-35% is very good, right? I was showing you before the crude oil price, green oil price would be $150 a barrel without subsidy, which is still good. Huh? I mean, don't get me wrong. If you really want to solve climate change, your crude oil price needs to go to 200. Now, I'd say you have to understand the GDP is not enough in the world to spend on energy. It's like your house bill. No? You're not going to spend more than 10%. So let's not get into the complication of economics. I did MBA, by the way, in between, so I understand economics a little bit. So anyway, let's do a mental exercise saying there's a big refinery somewhere in the Kutch area, and I want to be 100% off the grid. What would it take? And so this is what it is. The electricity demand is this horizontal line, and the sun doesn't shine, clouds come up every now and then. So those are the months where there's a shortfall. There's some months which is excess, but there's, unless you store electricity, that has no use. You can build a bigger plant, much bigger plant, to make sure it is 100% there, but then you're putting a lot more capital needed. And you can then, do it with the integration of the wind to lower it. Yeah, a bunch of other things. This shortfall is 30 days, okay? 30 days of shortfall. If you do all these other fancy things, you could get down to 15 days or maybe even 7 days if you're very clever. So let's assume 7 days. Today the solar plants are built initially with only 4 hours of storage. Now maybe they're about 12 hours and getting into 18, right? And India has done a great job with our electrical grid. It's all connected. We have a lot of fancy stuff on it in terms of control systems. I'm quite bullish that India can do this. US is completely out of the whack. I mean, they had to upgrade their electricity grid tremendously. Then we came with a concept called life cycle cost of storage. Because life cycle cost of LCOE of solar plant is what actually gets told everyone that the cost of electricity is low, lower than natural gas, coal, all this stuff, which is okay on an operating basis, but not on a delivered basis, but 24 by 7, 365 days a week. Okay? So if you include the storage in it, 100% storage to store a few gigawatts. So I'm showing here just say 1 day of storage for a gigawatt plant, 24 gigawatt hours. And with the known understanding of external technology, nothing competitive that I know of because I'm just looking at literature information. Here's the cost of storage, okay? And if you look at the last two lines, they're the green oil burning in basically a piston engine, like your diesel engine. And just think about it, no? In India, all the backup power has been all this time, nothing but diesel engines, right? For various reasons, we're outlawing it, but there's nothing that says, if you want to have on-demand electricity, I can burn the oil and make electricity as I need it. And that's exactly what this is. Actually, I went even further. Remember, I took this oil and went to the diesel, I went to Colorado State of Mines. They had the big diesel engines, right? So we started injecting this oil to say what happens. Nothing happened. You could inject up to 20%, I forgot the number, I may be wrong. But they showed this oil, because this oil is very light. You could blend it and you could burn it and there was no problem at all. So I got really bullish in saying, this is really fantastic, I should do this. I started promoting this idea at various, nobody wanted to hear about it. Everybody said excited, we want to be in the battery business, In fact, Ashish was working on battery business. After 30 spreadsheet, he wasn't sure what business he's in, but the battery business is needed, don't get me wrong. Don't get me wrong, okay? This is a different problem. You do need batteries for various purposes, whether they're for cars, for two-wheelers, three-wheelers, or for short-term storage. But if you need long-term storage, which will be needed somewhere down the road, this is what you need to work on. Maybe this problem is 5 years away, 10 years away, or maybe climate will change so fast you don't need it at all because we'll be all happy with the warm weather, right? May not have enough food, water, but minor problems. So then I started thinking about, why is the algae business so bad, right? Because nobody wants $150 a barrel oil when I can buy it from somebody. And we got excited by Russian attacking Ukraine and we got a discount and everybody's going crazy. We got a better deal on oil, right? But anyway, nobody's worried about how much CO2 we're making or climate is changing. And Ashish convinced me if I were to listen to our current president, it must be all hoax. So I'm fine, But regardless, just a mental exercise continuing. I want to start with photons and delivered electrons. What am I doing? In one case, I'm taking photons, using solar panels to generate electricity, storing it in, say, let's say lithium-ion battery. I'm showing a lithium-ion battery here. In other case, I'm making biomass. I'm converting biomass to oil and burning oil to make electrons, right? So this is really photons to delivered electrons comparison for 24 by 7. And I'm saying 7 days here because I don't think, if I have a commercial plant operating off-grid, okay? And let's say when sun doesn't shine, I want to shut it down and restart it. People will say, you're out of your mind. And if I say 7 days, they say, I need 15 days of storage. So obviously, for an operating plant, nobody's going to do this, even for a steel plant, okay? They would need a reliable backup power. And until the grid exists running on natural gas or something, we'll be happy. But if you want to do completely renewable, this is a problem you need to solve. And what I'm showing here is that if you burn oil to make electricity, for a 7-day storage, no battery in the world, even for 2 days, is going to survive at the cost point of this, right? And if one is allowed to do genetic modification, I know I kind of said something about my biologist, I call them gene jockeys, but they did something useful. You can do another reduction in cost, which I'm showing it here. Now, if you do all this stuff, this is really fantastic, but nobody's interested. So I said, okay, since I hired all these people and they're bothering me every day and saying, hey, they're so brilliant, I got to do something. So I put them to work. I said, okay, let's make different things, biomaterials or, make proteins and things like that. So they did a lot of genetic modification, do a whole variety of things. And so the couple of things I want to show that are actually happening. One is this spider silk. I think we worked with some of you for regular silk, but silkworm type of thing. But This is a very complicated biosynthesis where they put a gene module of about 32 different repeat. And it did work in algae, it did produce some, but it is very hard to scale up. So then I finally said, let's do this thing in E. coli to at least become commercially viable. So right now that's what we're doing. So they took all these chassis, put in E. coli, and I can do it under controlled conditions. But regardless, it can be done in algae as well. So this is likely to get commercialized. They've been given targets to finish the work, and now we have all kinds of people with spreadsheets and timelines and deadlines, so it will happen, right? The second thing was, what else do we do? So, people said, let's do proteins. We have a hunger gap and nutrition gap, and we produce some iron-fortified protein. So by the way, the protein that is produced is not genetically, I'm using genetically modified organisms, just like what we do for our pharmaceuticals today, in a way, right? So some people think this is going to happen. They also been given targets and have to finish this work and produce some money in the 60-acre facility we got. So they're all excited. So let's see in another year whether this happens or we say this is not our cup of tea, You have so many other businesses, so you have to compete in the real world. But these are really what I would call scientific activities which are mature enough and somebody to take a risk on commercializing it, actually developing a product. Because such products don't exist in the market today. And to be honest with you, we in India are not good with any product. I work with Ashish and Thermax on simple fuel cell. I thought simple, but we just couldn't compete with the Chinese and the Koreans. We couldn't make compact enough or productize it to the extent needed. And we lost patience, if you will. I mean, we should do it, but that needs a lot more patience and different thinking. So anyway, for a lot of people, since you have phones, everything is happening, digital world, Starlink is coming, you're all excited. It ain't going to produce food, water. I tell you, no. It's going to convert you to some slaves of some platform, and you'll be so happy that you're, right now there's only some surveillance going on. You speak, phone knows, and everybody else knows, right? Or when I type something, it repeats, it cleans up and writes something else. I even don't bother to check anymore. I say, whatever it is, just go. So anyway, what is going to happen in the long term is that there are only 10, 15 big platform guys, and we're all going to become what I call slaves of techno-feudalism. And the reason is very different. If you look at economics, the manufacturing actually, whatever money they made, they invested back as salaries in operating plants and this and that. In this economy of platforms, right? What does Amazon do? They pay only, 3% of the money they make to salaries? And maybe a few more for data centers. But bulk of the money is extracted out of the economy to do something else. You know what I mean? Just to make you buy things you don't want, most of the time. Since I talked about energy, these are my views, and most people will beat me up saying what the hell I'm talking about. But some of the things are related to, we have to transition from coal to natural gas, so that should continue. We should put a lot of money in renewables. Don't get me wrong. I'm all for renewables, right? But don't be confused that all the electricity we do with renewables is going to solve all our problems. We will need nuclear in large amount. And we have a lot of biomass. We are a bioenergy king of the world, I think, or somewhere thereabouts. So what do you do with this biomass, waste biomass, whatever it is? In my mind, instead of making bio-CNG, you should make this green oil. Take all the waste and make green oil. Green oil is storable, convertible, transportable, all kinds of stuff. But I'm the only fool who understands it. Don't worry about it. If somebody with money and somebody with power gets convinced, this may happen. But the two things, since I spent my time in upstream business in my previous companies, the fracking and horizontal drilling is going to help us with two areas. One is geothermal, and second is natural hydrogen. In fact, France just declared that they found some huge, and in the US some places are talking about too. And I was told by somebody in India there's some place you can find hydrogen. Anyway, we have to do all of this, but regardless, especially young people, you won't live in a 3.5 degrees centigrade minimum temperature, okay? We're going to have a shortage of water. Water will run out before most of things. We'll have shortage of food as well. So you have to think about investing in technology, infrastructure, and education to adapt to a warmer world. And I'm going to ask a couple of simple questions. I'm coming to the end, so don't worry. First is that can we grow forever from finite resources, right? And just think about it. In last 30 years alone, we extracted more resources out of Earth than previous 200 years combined. And with the population growth and our demand for higher and higher level services, all we're doing is we're extracting resources and polluting various parts of the Earth. Now, optimists may say we have all kinds of technologies, we're going to solve all this problem. All we need is money, right? But somewhere on the line, you're going to run out of whether they're rare earths. And there's fights going on rare earth without even knowing some people what exactly the rare earths are, but that's immaterial. You're going to run out of some of these materials. And then a real question is, what will happen? Some people think we should have a very planned degrowth. Americans were happy in 1950. I don't know why they're so unhappy today, but anyway, whatever is the reason. Overall, I was given a job one time I was a part of the team and working with World Bank and IMF and a bunch of other people to figure out a 100-year plan and what should my previous company do to do climate change. We did a lot of climate science. That could be an entirely different talk, but the whole idea was what is driving economics. So we did sector by sector, region by region. And I vividly remember in 1995, number of cars in California alone were more than the number of cars in India and China put together. Just imagine how the world has changed in just 30 years, right? And at that point, I thought the problem was unsolvable. So I think it has become more unsolvable today. And don't get confused by net zero and 1.5 and CO2 refining and all this other stuff. It's nice to write papers, get grants. Is it going to solve real problems? I'm not so sure. This is something I put some effort to figure out. What is ultimate sustainability? We have to live within the Earth's, some may go to moon and Mars, but none of us are going, okay? So we have to live on this Earth and we have to live with the resources on Earth. So we have to live within the sunlight. That's the ultimate energy other than nuclear or fusion, if you will, on the sun, And so what do you have to do? This is what it is. You have to recycle everything, you have to reuse it, you have to minimize its use. The economic model I had put together, if I were to put consumption tax, okay? And richer you are, higher is the consumption tax. That had a chance to solve this problem in 1995. I'm not so sure even in 2025. Nobody talks about it. Everybody talks about CO2 tax or this or that, because everybody knows nothing is going to happen, right? The only thing that could solve a problem is to reduce consumption of everything. Live within minimal. This is how we actually live, right? Now, how do we convince the rest of the world is the hard part. In fact, I have a presentation on that whole subject about how to convince a mass movement of changing their behavior. This is like a mindset change, So anyway, this is the ultimate utopian vision. It's not likely to happen. So, but just some young people to think about when it gets really hot, what to think. This become useful. Anyway, somebody asked me, what the hell did you do? Because most people think I didn't do anything in Reliance. That's just a perception. I mean, and in most cases, perception is reality, right? In fact, somebody very senior said, you wasted 16 years and did nothing. I said, okay. But I cannot ask a question, what the hell CSIR do? That cannot be questioned, right? But I'll be blunt with you. I've done a lot more to actually commercialize things in various areas and thought about developing something first of a kind in the world. Here in India. And all it was to motivate the young people, give them an opportunity to do what they can do, give them plenty of room, take all the blame on you, take all the successes just for them. It was all related to you show attention, affection, and appreciation. If you do that, and you do that right, young people will come through. And I have proof of that. And some of people like him can attest to the way I worked. Right? I had to take any idea, and I said, okay, you come with it, we'll discuss it. But when you come, that monkey is yours. When you leave, that monkey is yours too. It's not mine. You feed it, you make it work, or you kill it, it's your problem. I don't care, right? We can have a discussion, but there is no sir, yes sir, where I'm going to solve your problem. People used to come and say, I work for this famous professor. I must be good. I say, very good. But my problem is this. Can you solve this? And they will get really, really worried that, I said, there's no hand-holding here, man. I'm trying to solve some real problems. I'm not trying to make another paper for a professor. I mean, I would get fired right away. But anyway, this is where I never knew anything what a grit was. One day I was just talking to Ashish here or something. I was trying to make some fancy PowerPoint or something else. He said, use the word grit. I said, okay, maybe I'll just put it in for him, So in my mind, it's the greed, discipline, confidence, and future focus. Future focus is what will make you successful, right? And I say this to many young people, your attitude will decide your altitude in life. I'm serious about it. Get rid of this sir, yes sir nonsense. Have real confidence, be bullish, but understand the fundamentals of what you need to solve and how you're going to solve it. Okay? And you need to integrate science, engineering, and economics in your own head, yourself, or in your little team, and have some dash of common sense. Then you can solve complex problems. A lot of people talk about a lot of things going on, Vigyan Se Vikas, Viksit Bharat, all kinds of stuff. Since I was yesterday in UDCT, I was trying to tell the professors you should give something else to it. Don't teach them on your past, it's irrelevant. Just teach them how to learn and say what the future could be and what they need to be prepared for. So I gave you one reason. You should be thinking, what is your 3.5 degrees centigrade by 2050? So go figure out how the hell you're going to survive that. I will be gone along by that time, but you'll have to survive. And so the main problem is in education today is that they're educated, but they're educated just enough to believe what they have been taught, but not educated enough to question what they have been taught. And the only thing, competency I may have a little bit, and he can correct me, is to question everything that came in my room. I had no answer for anything, but I also had some tough questions at times. Maybe some completely idiotic questions at times. But those are the ones actually help us many a times. If I had not uttered the words photosynthesis, we'll be still doing genetic modifications and figuring out what to do. You know what I mean? So there are the times where you have to ask some fundamental questions. What the hell are we in? We're in an energy business. So go figure out what is the energy you're using to get the energy out. So anyway, these are my last couple of slides. I think you have seen this before. India has done well in the last few years. So incrementally we think what was there and what is now. But the rest of the world has done well too. And just look at how well China has developed in the last 30 years. In 1990, we were probably the same, China and India. In 30 years, they have leapfrogged the world, essentially. So we can do it too. So it's not just the economies of scale and scope that is going to get us there. We have the same 1.4 billion people roughly here and there, like China. Is the knowledge and economy of integrating that knowledge in a smart way that will get us there, right? You have some long-term plans. And I won't talk about China, I can give an entire lecture on China, but they've done well, and we had to learn from it. Now, when I first came in, and this is something probably Ashish will not like, but I have to say it. I went to a lot of places and say, okay, I have no facilities, let's start working together. And to me, most of the time it was like a baton. Somebody will do something and say, this is yours. UDCT did it many times. And I said, look, what do I do with this? I want to run with this. The baton may get fall. I want something where everybody's work together all the time. And once you start end-to-end, I say, oh, there's a value in what I did, the valuation, right? Then I say, okay, great, you created a lot of value. But there's zero value in my head until I commercialize. So if you wait with me, and when we commercialize together, I'll give you a piece. I cannot give you a piece ahead of time when I don't know what that value is, right? And I used to do this licensing business with startups in the US, and I developed a very comprehensive model. I think I shared with Ashish one time. It's about how do you develop the partnership and how do you convince what is it for you, what is it for me. Because the biggest risk is the capital risk, not the intellectual risk. Unless you put a real capital, there's nothing real. And so you have to think in those terms of how do you share it. Anyway, Prime Minister Modi a couple of years ago started talking about cut out your sir, yes sir, servitude mindset. I've been saying that at least for 17 years, right? The day I showed up. And the day I left, my secretary still called me sir, geez. I used to tell them, what's wrong with you guys? This is something ridiculous. Unless we have a common language and talk equally, we wouldn't be able to do something collectively better. So anyway, in my mind, it's simple. The fast followers will never become the leaders, okay? This is what the tagline is. And especially when the big things are changing, whether it's the fourth industrial revolution or whether it's climate change, if you don't take a risk, you ain't going nowhere. We'll middle with the mediocrity. In fact, sometimes I wonder, we get confused between meritocracy and mediocrity. To be blunt, we started normalizing mediocrity as if it is meritocracy. At least in my head. I may be wrong completely, but that is something we need to absolutely change. And those last couple of pictures were from Dr. Mashelkar, so I must give credit about the sheep and the, the flock of geese, I guess. It doesn't matter what it is. I steal from, steal from everywhere, but put your own thought of what you're going to say. If you just regurgitate what is being told to you, then you're completely useless to me, okay? So anyway, I guess I've been talking about translation and research to ICT guys, and they say, hey, now we're going to do all this stuff. So I said, I'll offer my services. They're thinking about it, but anyway, inventions matter, keep in mind. Innovation is great. I'm not saying don't do it. You have to do it to earn some cash flow, so you can do something more useful. But if you do only innovations, you'll only remain mediocre, at least in my perspective. May not be in some other perspective. And what do I know? I'm not that famous or anything, so I may be completely wrong. But if you do inventions, you'll certainly be successful if you commercialize them. And I've done that in the last 45 years, okay? I have more than 200 patents, by the way, and 70% of them are commercially useful. Just think about it. Anyway, so this is the second slide I had given to Mr. Ambani 17 years ago, how I think about how to do research, or for that matter, any damn thing in your life. And I put it here for creativity to commercialization. So, and I think he's familiar with it. Every time somebody shows up with impossible problem, I take this graph. I say, where are you on this, right? So you're starting a new problem, you're an explorer. You're doing all kinds of exploring. Then you come to me saying, "Arey boss, I did so much exploration." I said, fantastic. So I said, okay, I'll give you a palette, a brush, go paint it, right? Then he'll come back with various paintings. I said, "Abhi kya karna hai?" I said, "You are a great artist, right? Now we have to choose one." And he says, "Oh, boss, you choose it." I said, no, you're going to choose it. You have to be the judge in saying of all these things, which is the one that you're going to take it forward. And that's the hardest part, to be a judge. That's the hardest part. It's okay to be creative, generate all kinds of stuff. And in academia, you can write hundreds of papers and get fancy, colorful gowns, or maybe even brass plates, or whatever the hell we give these days. But if you can judge, then you have to be like a warrior. I'm going to take it forward, hell or high water, right? So I call people, I need people who are the belly, fire in their belly and lion in their heart, right? This is my another favorite phrase. I'm just reminding Manoj what he was taught. He's forgetting now. He's in Pune too long. But if you do this well, I'm telling you, if you do this well, you'll be successful. Here's my last slide, and this is I stole from Dr. Mashelkar again, but I changed the words completely, right? I mean, the whole thing is all about is what? I in India should be about inventions. Innovation is more for implementation. If you get that in your head, you'll be very successful. But anyway, imitation doesn't work. We learn hard ways, right? I mean, maybe in some cases it is, but that's not that. And everybody quotes Mahatma Gandhi, so I also put a Mahatma Gandhi. Man said something about inventions. He never said innovation that I know of, right? So maybe we should believe in our father of the nation and start thinking about inventions. Every day you go, I say, what the hell am I going to invent new? And bother Ashish, saying, I got so many ideas, I'm an artist, please give me. I'll send you this graph if you want. You put it in the. But the hardest part is you have to judge it yourself. Okay, so don't make 1,000 paintings. Just make 2 or 3 and bring it to him. Then likelihood of getting some success is much better. This is my last slide. Never stop dreaming. I stole it from somebody. I don't know who the hell, but it sounds good, no? Never stop dreaming. Never stop believing in your dreams. But this middle line is mine. I'll take full credit for it. I tell young people, you start something unknown, and one day if you follow that chart I showed you, you will be finishing something unforgettable. And the simple story is my catalytic gasification. It was a completely, one day somebody showed up and it was completely out of my head. I said, "Arey, oh, homogeneous catalyst ko heterogeneous kar do." I never thought these guys will come back and actually have a catalyst. And they followed that chart. They came back with 3 paintings to me saying, "Abhi boss kya karna hai?" I said, "Very good, now we have to do something." So he said, "This is my first idea." So I said, "I sent to Utah, I sent to somewhere else, do some experimental work in some facilities." Remember that? And then they came back, I said, "Hey, this painting looks good." I said, "Very good, let's push it hard." So I was helping them write notes to Mr. Ambani and others, whosoever wants to hear. I went to Niti Aayog, I got beat up by Coal India, I got beat up by everybody. Say, "You're stupid, what are you talking about? In fact, some of the famous people from Pune who had gasifiers being built here were telling me, this is all nonsense. You're talking about solid reacting, such things don't work. I said, okay, I trust you, but what has worked in your lab? I still haven't figured out. But whatever it is, people are interested in gasification in India. And once we demonstrate this for biomass, I think it has use for coal as well. And the clean coal, probably much cheaper to do it. I guess since I was ICT, this is a picture I had to show them because I just wanted to make sure that I know some of these famous people from ICT. But the reality, the only person I heard, the day I left in 1976, Professor Sharma said, go ahead. The day I decided to come back, I called him up and should I come? Okay. Then he gave me both pros and cons and painted various pictures for me and asked me to pick my picture. Then I went to my mother and I said, Abhi kya karna hai? And that's how I ended up in Reliance, right? The other two people, they're very nice. I talk to them all the time. Once in a while something good comes out. But you have to extract what I call the fundamental knowledge of all these. They're great people. They've done a lot of work, they have a lot of experience, right? But what I meant is that you got to figure out what is good for you. And if you can do that well, you'll be very successful. Sorry I took a long time. But he said I had to tell stories. I had to make up some stories too, right? Thanks, Asit. This is Ashish. Yeah, that's the fun part. I don't know why I gave slides. I should have just stood up and asked questions. No, but I want to tell my story because there is a perception out there that did we ever do anything useful in Reliance? And I got really surprised that there's such a question, And actually, music to my ear was A.V. Ramarao, who's supposed to be the father of pharma industry. After listening to one of my talks, he said, hey, you've done a lot of work. Sounds like you've done more than CSIR. I didn't want to disturb his mind, but he said that, okay? Yeah. That's where I came back and said, CSR could be CSR. Yeah. Sorry, this is just a joke. Don't take it too seriously. Ashish knows that I like to push the boundaries on everything, right?
Yeah. It was very inspiring. In India, we always talk about innovation. Why we don't talk about invention? Like most of the leaders, they always say innovation, innovate, but invention is hardly spoken.
I think you should ask that question of them. I'll give you my perception, but so you have to understand, when I was growing up, we were very poor, okay? We were shit scared even to go to Professor Sharma's office. We would check under the thing whether his legs are this way, that. We will check with the peon outside. I asked, boss ka mood kaisa hai? He said, he doesn't know. So he doesn't know, then we don't know whether we should go in or not. 90% of the time we didn't go. 99% of the time we didn't go, to be honest with you. We were so scared, right? So I think it's the scarcity mentality, and other is this whole import substitution. We haven't really gotten out of that mindset. I think it was okay till 1999 in my mind. If you stay in that mindset and you're risk averse, in my mind the most important thing is we are risk averse. And the bigger the risk we have to take, we need somebody to tell us and hold our hand. So unless we snap out of that, and there's nothing wrong with innovation. Innovation is needed for the society. Don't get me wrong, okay? I'll tell you from my perspective, okay? You should do innovation 20% of the time, and 80% of the time you should be inventing as a CSR lab, okay? When you come to me, it's 80% invention, 20% innovation. When I said that to ICT yesterday, some bunch of professors slapped me around. I said, okay, for you I'll be 50-50, I'll be happy. Don't beat me up, okay? But it is your personal thing, and this has to do with, if you just, let me be more philosophical about this invention innovation, okay? It is really nothing but a risk and reward. Invention is a lot greater risk. Innovation is a lot less risk, and probably chance of getting a reward are much higher. That's all. So if you just remember, invention, innovation is risk reward. All the other stuff I said, you just forget about it, okay? That's good for me. There's a story because he asked me to tell a story. But that's what it is. And the risk and reward is really a mental challenge of how we grew up and where we are, right? But India of today is very close to India I left, or even close to when India I saw when I came back. In 1976 when I left, there were only 400 million people in the country. Today we have 1.4 billion people, right? But not only that, we are the third largest number of billionaires in the world. And for the first time this year, China's number of billionaires has surpassed USA. Just think about it. Just think about it. And a billionaires is not an indicator, but it says that we're doing a lot better for a lot of people. Although the gap between the rich and poor is increasing everywhere, including the US. But the fact that ability to take a risk is higher now in my mind. Because economically, we're much stronger. We're talking about now what, surpassing Japan or something, right? Now I have an entirely view on economics, and I can give an entire whole lecture on what the hell economics really means, right? I mean, the purchasing parity and all these things are great, but at the end of the day, it's the GDP per capita, right? Is everybody well off? And on that measure, we are not anywhere close, okay? We still maybe bottom 30% as we were in 1947, because our population has gone up so much more. But economically, everybody is doing well. So it's not, the way to look at it, India has done very well, right? Compared to Africa or South America. But should that be our, I mean, if you really want to be a superpower and be a well-known, I would say you need to only look at China. That's your only competition. That's your only thing. Our neighbor has done well. Why can't we do it? Go figure out what the hell did they do. And somebody says they are communists, we are, I don't know, what are we? A democracy or something? It's got very little to do with that. It's a mindset, okay? I mean, Chinese economy is 50-50, no? It's 50% private, 50% government. We're not that very different, to be honest with you. Anyway, what do I know? I'm just a simple engineer. Yeah? Good question, though.
Very interesting presentation, inspiring all of us. Your project on algae at Reliance, coming out with bio-oil, seems to be a very interesting project.
Hey, green oil, huh? There's no bio oil. It's only green oil.
Green oil.
Yeah, bio oil, nobody understands.
Okay.
There's so many oil. And I put bio oil on my head sometimes, body.
Okay.
Green oil just sounds like green hydrogen, right?
Yeah.
So green.
This green oil was from algae, you meant to say?
Any organic material,
Okay.
municipal solid waste, dead
Yeah,
bodies,
That's very good.
even poo,
Now, you see, I mean, there is a good opportunity in India, particularly in sugar industry. You see, we are making bioethanol, and each ethanol molecule use one more CO2. And that food grade CO2 is available all over India.
I don't need a food grade CO2 either, right?
Yeah, it's okay. What I meant
Manoj,
to say, this CO2...
don't sleep, man. He's asking important question on algae. You are the boss. Sorry, yeah.
Yeah. And somehow people are interested in this project. I mean, CO2 to what I should say, algae. But somehow, I mean, what is your opinion? Why this technology is not getting propagated?
I think it's too complex for where we are in our state of development. You have to understand where I come from. There's one thing I learned in India, I think I must say, and I'm sure the guys who are on, they will all go crazy, but it's okay. I'm retired, people can kill me, no use, no? My experience in the US was when there's a difficult problem, people came together. In India, it's exactly the opposite. When there's a difficult problem, people run away.
Yeah.
People simply run away, okay? Now, take it as my personal mistake of not understanding, or maybe I don't understand what is running away or what is being together, okay? But whatever it is, when there's a difficult problem, I have not seen people come together, okay? There'll be so many people infighting, backfighting, sending notes, ye hai, wo hai. They may not even have a clue of what it is, but they have an opinion, right? And we express our opinion at the highest degree to kill something. We will rarely have an opinion to say, how am I going to make it work? And that's the difference. Now, don't get me wrong. When I say $150 a barrel oil, nobody's interested, right? If you really want to solve a climate change problem, then it has to be looked upon. But if you give up and saying it's going to warm up anyway, why bother? Just get rich right now. Well, it's a different thing, no? But to me, I'll comment on biological CO2. Because to me, it's not a problem. It's within the carbon cycle of the earth. It's the fossil carbon, which is old biomass buried, and that is the problem. So if you have a biological CO2 coming today, I wouldn't give as much priority as the CO2 we're making in all other places. And let's take care of that first. I think I told this to Ashush, and he said, no, everyone's interested in this biological CO2. I said, okay, you want to make methanol out of hydrogen, and then whether I have to take this transport the carbon, whether it is fossil or biological, maybe you have some interest. But to me, making both those, ammonia and methanol, is let the rich country do it, and maybe we should do it just for them. But don't count that our economy is going to do it. That's my problem, my opinion. I may be wrong, because there are some better, with much finer pen to do spreadsheets, right? I don't do spreadsheets. I do only back of the envelope calculations, right? So if they make sense, they make sense. If they don't make sense, then I give it to somebody who says, okay, go figure it out, I give them my circle and send them out. If they come back, then we can have a chat. See, as a boss, I had simple solutions for everything. See, Ashish never had a problem with me, because whatever he did was great. Right? On the other hand, Manoj will come with the difficult problems, Then had to change his jobs a few times. Sorry, Manoj, I'm picking on you, but it's the reality, though, no? And he excelled in every job. That's the good part. Sorry, you had a question.
Yeah, so I just wanted to like pick your brain on what do you think is the future of the bio industry, especially with relevance to some of the points you had in slides, like having green jockeys and they really not being able to talk to each other to solve problems. The fact that it is bio is very high risk, very capital intensive, and our mindsets are really not in the place. So how do you put everything together for India to
Actually, the bio is, I believe, actually, I've made this comment many times. This is the century of biology. The century of mathematicians, chemists, and physics is all come and gone. Because with the climate change, no, I'm just coming to that. So I think what we need to do is, we need to figure out, see, for pharma industry, bio is absolutely what is driving the future, right? So can we come to fine chemicals? Jumping onto some really complex, large volume chemicals, and even this green oil I'm talking about, is quite complex. To put a realistic green oil plant, right, it's going to cost us like more than $2 billion, right? And then the funders look at it saying this $2 billion can fetch me better returns somewhere else. That's always going to be the case, right? So there are cases where I think the government need to take that risk. So I think the government has incentives, but see, our government is also following, and I'm not saying nothing wrong about, Brazil did ethanol, we should have done that many years ago. Bio-CNG, somebody told me Indian Institute of Science invented it in 1850 or something, or whatever. It's a long time ago. But somehow we lost the cloud and the Germans picked it up and it's coming back. Don't get me wrong, there are good things to do if there are no alternatives. And since I'm so passionate about green oil, I feel like that's all. There's green hydrogen, there's green bio-CNG. Why is not a damn green oil? You know what I mean? But anyway, I think the bio industry has a lot of potential, especially in a climate change world. And the first thing you need to worry about is the food. Because if the Indian monsoon goes south, you will know that 10 years ahead, because the West African monsoon will have gone south. But that is very little time, right? As it is, our monsoon is getting erratic, right? So what are we going to do for water and food, and how is the biotechnology going to help me at least on the food side, right? So this protein business I was talking about, maybe from algae, we're trying to do as more like a vegan. But there are other things you can do on the food side, on agriculture side. When I went to Philippines to figure out, God knows, there are like 300 scientists working on just C3 to C4 rice. Because rice is the most abundant crop, and at least on the poorer countries, right? And he told me it's going to take 40 years. 40 years to go convert a C3 rice to C4 rice. It's a very big roadmap. It's very complex biology. Maybe you can do it in 10. If you can do C3 to C4 conversion in 10 years, you will be the Nobel laureate. I'll trust you. Huh? So I think the biology for food is more critical. Then obviously pharma is always going to be critical. Some fine chemicals I was talking about this afternoon to people. So they have some niche products, right? They can be done in, I guess, these fancy micro reactors much more cheaply. And they have value, right? So those are the kinds of things you have to look at. This is this whole idea about how do you go from concern to confidence, right? Concern to confidence is the word. More for the types who are going to invest. You come to me or Ashish, you'll be all excited, no? Okay, we have no money. The guys have real money and want to make more money. They're the ones who need to be convinced. Now, Ashish has money because he can support the projects and get them going. But you can go up to TRL, God knows, 6, 7. I don't think you can go to, you got 4, 5, yeah. So there's something beyond TRL called MRL, right? After you reach TRL 8 or 9, then you have to think about manufacturing readiness level. And God knows, what, 5 or 6 levels or something like that? 6. Those are the most complex ones. Those are the most complex ones. Many of these technologies TRL 8 and 9. They haven't happened for various reasons, right? Because people are trying to figure out, and it'll happen, but it takes time to get these MRL guys to, MRL stages to actually make it happen. So I would suspect, to answer your question, you start with a high value, low volume, low capital intensive business and build that momentum to go from concern to confidence. Does that help you answer a question? I'm like a politician, I can avoid any answer. I can handle Indian politics and not even the US politics. So, sorry.
Nuclear energy, but I don't think you elaborated more
Oh,
on
I
that.
have a whole presentation on nuclear if
Can
you
you
want.
just give us a brief idea about where we stand as a country in terms of nuclear? It doesn't get talked about that much.
What
Perhaps
do you
the
mean? JB
scalability.
Joshi is working on all kinds of SMRs, and Dr. Kakodkar gives pretty elaborate conversation. I think my view is very simple. In 1999, some US guy told me India is a leader in thorium reactor. And I still wonder why we have not been able to commercialize. I'm sure there are some real reasons. The Chinese have commercialized it, right? Chinese are the only ones who have done the 4th generation nuclear reactor, as we say, right? So, I don't know, I've been to BRC a few times and I've been shown around. So we have pretty smart, capable people. It's just that we're going to take that risk of building something. And we have a lot of this political activists and trying to get anything approved probably takes time. So the SMRs may help in that regard, because the safety area needed, and if you do a cookie cutter design and do multiple of these, it could reduce the overall cost. And I think we are moving in that direction. I saw something in somewhere, the Indian government has now made pronouncements for going pretty big on nuclear, right? But then comes the question, what is the future of nuclear, right? And I wrote a paper about 6 years ago, 4 years ago, I forgot, on fusion, right? And I sent it to all the big wigs, like I always do, Just lost his mind or something. To me, the fusion is moving a lot faster than anybody anticipated. It's attracting the most amount of investments in the world. And there again, I'm told Chinese are way ahead. I don't know if they have an operating demo plant, or, people say you cannot trust what Chinese say. I've been hearing that for the last 50 years. In fact, I had a guy in my planning group, remember? He used to come every day saying Chinese are collapsing tomorrow. After 12 years of hearing this every day, I said, hey, what's going on, man? Yeah, nothing has changed. Looks like they're going ahead. So I think bad-mouthing China, those days are over. We got Trump and others to worry about it, no? I think, didn't we read something that now the elephant and the dragon are dancing together or something? That's what we need to do. You have to look east. Forget about the west. West is doing its own issues. So I think we have to accelerate nuclear, and you got to go figure out how to make it work faster, and also get involved with fusion because it will happen. I think I wrote to somebody saying, then they say, I said 2030 is a good time frame. They say, no, don't bother me till 2030. You will be dead, I'll be dead. I said, very good. The rest of you will still around, no? Amol has no question. I'm impressed. Yeah, I mean, I think when I was talking about, I think you have to understand, there are two things we were tasked with in 95, 97 time frame. One was, let's assume climate change is real. I mean, scientists always believed it, but you have to deal with a bunch of other people too. No? So let's assume and go through this mental exercise. What should we do? I said, very good. I said, I can't even figure out what to do in next quarter. But then all of a sudden I realized the 100-year plan is fantastic. You can dream of anything you want and you can put together, you can work with the World Bank and other things like economics and everything, right? So what it was we were doing it by sector and country by country, all major economies, right? Even small economies compiled together. We had a pretty good prediction on how much oil would be needed, because we're an oil business, right? And what would the CO2 concentration be, and how much warming would happen if at all it is real. And those all are coming very true. Other thing, most important thing we figured out was, if the earth is warming, the stratosphere has to cool. I mean, the net energy balance has to be there. Until recently, that is broken now because Earth's albedo has gone down and we're retaining a lot more energy. But coming back to the question, so we put all these economic models together, and then people said, okay, now we have to really solve this problem. What should we do? So then we said the best available technology at that time is going to cost us 10% of the GDP. Okay? At that time, we were talking about solving problem at the global level. It's a global problem. No? It's not just one company can solve it. So just to give some context of what could be done. Then said 10% of GDP sounds little too much, right? The funny thing is, the McKinsey just published a report a year or 2 years ago. Now the economy is much bigger. The number is about the same, 10% of GDP. Every year, from here on till the cows come home, as they say, right? So it can be solved. It could have been solved cheaper a few years back. Every year that goes by, it becomes, on net basis, expensive. So then the question comes up, then how do we find this money? I mean, going to politicians saying, "Hey, boss, 10% of GDP," Then you come up with some fantastic projects saying government can fund $100 billion here or there, we'll solve the problem, right? So you come up with these solutions which are, for sure, not real. But that puts you in a framework of saying what degree of magnitude one needs to spend. Then this whole, there was this whole idea that, for acid rain it worked, that you can come up with a carbon, you can come up with a market and let market do it, right? That's where the CO2 tax came in, right? Then say, how much CO2 tax? It again came out, I think at that time it came out at $100 a ton. $100 a ton was again not palatable. So we said, okay, let's peddle $60 a ton. Nobody listened to that either, right? But then we were looking at alternatives just within the community of the small team working on it. Then we said, what is the real problem? Real problem is consumption of everything, right? And so if you were to put consumption tax based on your ability to pay, would that reduce the consumption? Now, it was a little bit cheaper, not a whole lot, because the technology was the same. You're just taxing people more, right? It's like today what's going on with tariffs, trying to figure out who's paying is actually the customer, right? The same thing. But the idea was that the guys who are consuming more, independent of where they are, should be paying. In India, China, rich people should pay. Why not? Then the other question was, we had this whole globalization mindset. I'm talking about US mindset. I was working with the US at that time. And the whole globalization is what? To use resources somewhere else and cheaper labor somewhere else to satisfy the consumption needs of rich countries, right? So all this thing came out that rich countries will have to pay more, no matter how you look at it. But I said rich countries, it's not rich countries, rich people everywhere. right? Rich people everywhere. What's wrong with that? I said, then how the hell are we going to agree with it? Because this model of country by country putting targets, is what everybody thought is a good idea. I don't know why it's a good idea, but that's what has been with all this COP. And then nothing but there's a technical committee is doing their thing, and then there are all these politicians trying to figure out what could be sold to their own constituencies, right? So it's not a solvable problem as a result, right? It's not solvable. A lot of people get excited about net zero, and I'm the only fool who says, yeah, net zero sounds good, man. What do you do with it? We have never been at zero anywhere. So why do you think it will happen in the future? The other thing we were always thinking about was the technology of the day. If we invest in R&D, better technology will be available tomorrow, and that can be deployed at a larger scale on a net present value basis. It will be less cost. That was another beautiful gimmick of spreadsheet, right? Because we could say, we could paint a picture, it's like painting a picture. No, I can paint a picture saying solar will come down by but solar has come down, right? The wind will come down, some new technology will emerge, it will be so much less. Batteries will be a factor of 100 cheaper. You can make all those assumptions, saying, okay, when would they happen? Then boss will ask. So you make one number, 2010, 2025, 30, just. And then you run through a spreadsheet and say, yeah, it looks cheaper. Then all the economists would say, hey, fantastic, man. This guy is brilliant, So you push the problem tomorrow, hoping something better will emerge and you'll solve your problem, right? And knowing fully well, in fact, we had all these curves about capacity versus cost reduction, right? Learning curves. So we'd put those in, confuse the hell out of people, saying, yeah, at what rate technology will improve, its, cost will come down, a greater penetration will happen, all that kind of stuff. I know it's, G1's paradox is something you heard from Sivaram probably, right? When something comes down, demand goes up and all kinds of stuff happens, right? So we put all that stuff in to confuse the economist even further. But they thought we were just brilliant, We had all these complicated equations, this and that, and the boss was very happy because the problem is for tomorrow, not for today, So whichever tax you look at it, whether consumption tax or CO2 tax, but if you just mentally think about it, the consumption tax has a greater appeal, right? It kind of makes sense. The people who are consuming more should be paying more. What's wrong with that? Then it becomes too much of a socialist type of thing. No, it's not capitalist. Right? Think about capitalism. Right? I don't know. Did I answer your question? The bottom line is we don't have a really good answer of economically how to solve it. And if you believe in today's capitalistic economy, where the growth is absolutely needed, otherwise you won't survive. What do you look at? What is my interest rate on FD? You know what I mean? If it drops down, you go crazy. If the stock market drops to 5 points, you go crazy, right? Because all is predicated on growth. So I've been reading quite a bit about this whole degrowth business. It's also very romantic. There's all kinds of books written, donut theory, this theory, all kinds of theory, But the bottom line in that all comes down to is that if you don't do something, the societies could collapse economically. And that could be far more devastating, right? And so historically, if we look at, what happened to Mayans, I guess he was telling me something about Harappan, that guy sent me a paper. It's not a natural disaster. The resources in that limited region got exhausted and population couldn't survive. Same thing happened to Mayans. The same thing happened to different parts of the world. Now the question is, unlike the past, we are globally connected. And if we stay globally connected, what does it mean? So there are a lot of economic models of which economies will collapse and when. The when is the hard part. But the way to look at it is that there is a possibility that the current economic model will collapse. We cannot grow forever. And the techno-optimists would say new technology will solve our problem. It has done it for the last 2,000 years. Maybe it is true, but maybe it is not. Because things are accelerating much faster than we ever anticipated. And it's really simply in my mind is that how fast does it take to implement a capital to get a return and at what scale you can do it. The problem is the scale. The scale is enormous. It is not a trivial problem of biotechnology of saying I do some molecules and put some small plant. We talk about the entire global scale. So at that scale, You know what's going to happen, to be honest with you? When I explained this to Ashish some 3-4 months ago, and he thought I was in a fantasy land. But, other day I got a paper from somebody saying China is screwing up climate change. I said, what happened? Oh, so I finally explained it to him. We took sulfur out of all the fuels, right, because of the acid rain problems. But sulfur aerosols, which were reflecting part of the sunlight, has gone down, right? So suppose that climate change, all our models are wrong, which probably are, right? And let's assume the worst case, we are warming much faster. What would you do, right? Now what would you do is actually you will have planes go up to stratosphere and start spreading aerosols, sulfur aerosols at a global scale, right? That will cool the world right away to some degree. And it's like a thermostat. You want to tune it down by 1 degree, here's how much sulfur you have to put in. So it is doable. And there are all kinds of other geoengineering solutions, but this is the most plausible one, cheapest one, and can be implemented, right? But the real question comes up is that who is going to do it? Probably northern countries will do it, right? But they have the plains, they're rich, and they can do this stuff. Then who is going to suffer? Because somewhere the acid rain will have to happen, right? And it will be more likely, most of the models suggest it will happen near the equator. So, do we have a choice in this, a voice in this, or whatever, right? We're not even aware of what the hell is going on most of the time. So anyway, I saw something in United Nations. There is a bill by Global South saying rich countries cannot do this global engineering without our participation, right? Will that stick? I don't know. I heard somewhere Mr. Trump is saying, why should we be part of United Nations? Then what happens? So, a lot of unknowns. These are all political questions. And, so they are not solvable questions. They were not solvable in 97. I'm not so sure they're solvable today. The technology has improved. No? The cost, the Chinese helped us to bring the cost of solar down much faster than in my economic model. Same was wind, right? Same with EVs. I mean, they made it much faster progress than those models we had put together on the curves, right? So maybe something will happen where we participate, we bring the cost down rapidly with our jugaad and our ingenuity and inventions. I don't know. The trouble is, though, the rate at which the things are changing is much faster than we anticipated then as well. Because never anticipated the Earth's albedo will go down so fast so soon. Yesterday somebody was arguing with me saying, he did his PhD on CO2 and others. He was telling me the CO2 vibration. I was trying to explain him how actually the climate change works. And how each molecule in the atmosphere and its concentration and the vibration frequency, and how does the energy that comes in gets converted to infrared radiation that leaves. They started bothering me saying the CO2 vibration frequency is only within a very narrow range. This just is impossible, right? So he was one of the probably climate deniers. So I said, okay, you're very right. I agree with you, right? I agree with you 100%. CO2 is not a problem. But there is a problem. There's something's happening. Something's happening. What is it? And then I tried to explain him, whatever it is, I don't care. It's CO2, methane. Then since he started talking about hydrogen, I told him, one thing you don't understand about hydrogen is that the leaked hydrogen, okay, actually is eating up the hydroxyl molecules, which actually help reduce the methane time span, right? So more hydrogen gets released. What you're thinking about is the half-life of methane will increase. And methane has a much higher, the forcing potential, right? So I was telling him, somebody said CO2 is a 200-year problem, methane is a 25-year problem. We don't know how much methane we are releasing because everybody's on a natural gas bandwagon. In 90s we used to complain that those goddamn Russian pipelines are the ones causing methane leaks. We are very tight everywhere. I don't know. I'm not so sure. With the industry grown so much more, whether that is really the true. Somebody is measuring methane from satellites anywhere, and they say it's not true. Methane leaks are everywhere, right? So it depends. So to answer the question, if I believe in the scientists, I read a lot about this, by the way. I've been reading about this since 1990, so I may be completely confused, but whatever it is. There are a couple of people I really believe, like this James Hansen fellow in the US, and a couple of other guys, and one guy's in Canada, one guy's in Europe, in Japan. I read all of them. There's a consensus amongst the best scientists that the climate change is real and it's caused by these various molecules. And somebody can argue till the cows come home in what range of nanometer frequency these things vibrate is real or not. To me, it is real. Because my insurance rates where I live in Tampa, the water has gone up by a factor of 3 in 2 years. Because number of hurricanes hitting us has gone up. And I had to evacuate twice last year within a month, right? And the only economists I believe are actually actuaries, because they have a pretty good understanding of money and risk, okay? No, I mean, they're not laughing matter. They're more serious than the Wall Street types, I did my MBA, by the way, in Cornell, and actually my class was in New York. We were only 30 students, and most of them from finance, from Wall Street. So I know those guys exactly. And 3 of my classmates went to jail for various reasons. I won't go into that, but what I meant was, if you look at the serious economics who understand risk and the cost, there's a consensus report written by actuaries across the globe, and that essentially says none of our models have any value of predicting what will happen in the future. So they look at the risk and they say in their models, in 2035, there will be a 500 million people migrating from south to north, because the wet bulb temperature will not be able to survive human species without air conditioning. And more air conditioning, more global warming, right? And poor people can't afford it. Second thing they say is that most of the assets in the US along the coast will be uninsurable. And that's what's happening in Florida today, right? And I'm saying I live on the 18th floor, by the way. I mean, I may be on the water, but what's the likelihood of me getting flooded on the 18th floor, right? But that's not the issue. The issue is that I have to bear the cost for everything else that happens, right? Now, if I really believe in this, some scientists are talking about AMOC is going away. Now, don't ask me what is the full form of AMOC. You can just Google it. But this is the Earth stream that goes around. It takes 200 years. Okay, 200 years. And if you think about it, the explanation is very simple. What happens is that when both the poles start melting faster, then the fresh water is getting faster. And what driving is this difference between the salt water density and a freshwater density. And so moment you have this fresh water at a rate at which it's going in, is going to slow down this pump, okay? And that happens, not only the sea level rises much faster, but our weather pattern all over the world go haywire, completely haywire, okay? I mean, I was trying to scare you about monsoon. Forget about that. If this thing happens, there won't be any monsoon at all. Then what do you do? So these are all predictions of models that you can trust or not trust, right? I mean, it's hard to know. When you're trying to put these global models at a scale at which we have no understanding. And the tunable parameters exist, and then somebody told me AI is going to solve this. I said, oh, fantastic. Here comes AI to solve my problems, right? I have actually an entire presentation on AI, and actually I wrote something 8 years ago, what should we be doing? And had we done that, we would not be in the same, we would have been a deep sick, right? Chinese. Because I used to work on this stupid thing in 97, not 93, to be honest. And I had this big group, 200 people working on all kinds of technology, right? And for us, refining technology is what? Digitizing things, making data available remotely to anybody. Everybody wants to see my CEO, want to see profit on a minute basis. All kinds of shit like that. Sorry about my language, but what it was is, the bunch of people working on advanced control and bunch of people working on real-time optimization. I was one of the first guys to implement RTO with advanced control to the entire plant, okay? And then we were doing this molecular modeling that you may have heard of. We were trying to integrate that into all these complex systems from planning to control, right? And then it became too complex. Then I had all these guys saying, hey, we got expert systems. I said, okay, expert system. So I had like 15 people work on expert system. They'll go talk to people, try to code their knowledge into this, and so people can solve problems. And what it was just simple neural networks, maybe 3 layers. The back propagation to tune wasn't there that Hinton developed. Neither did we have so much data, and our computers were not that fast, so our models were limited. So if I think about then and now, so I had this problem. I said, what if I were to integrate these neural net guys and these modeling guys? And the modeling guys had this very, once I integrate this molecular composition, the matrix is very large, and I had done a lot of work on this biconjugate gradient methods. I had written a paper in 84 or something, how to convert, million by million matrices with very high speed. And I was doing that for fluid mechanics, right? But we were applying that for all this compositional modeling business. And we had come up with the ways in which we could refine it when needed. So then I came up with an idea saying, what if I take all these neural net guys and integrate this with the so-called known science, right? And none of us could figure out how to do the math. But it was clear to us in both methods, there was one thing was common was some version of Newton's method. Steepest descent to get to an optimization. So I went to the best minds in Carnegie Mellon because I was hiring PhDs, like every PhD from Carnegie Mellon, they had an open offer from me. Because I was building this group and trying to do all kinds of stuff. So I went to all these famous people, Grossman, Westertup, what was the third guy? Larry Bigler, all those guys. I said, I had this brilliant idea. I want to integrate these two at the level of the inversion of matrices, right? They looked at me and said, you're stupid. I said, why? Then they started explaining me, some problems are solvable that can get funding. Some problems are unsolvable, they're not getting funding. They said, you can hire these 2 people and you solve yourself. That's not our cup of tea, right? And then Grossman came and told me and counseled me saying, this is impossible with today's technology, right? I walked away from this. I came back, I started bothering these people. I went to Triple IIT Hyderabad, so-called our data science gurus. I gave them a lecture on my ideas on neural nets and new algorithms, and I read this complex book called What Exactly is AI, and so then they characterize this in 5 categories. And it all comes down to, there's a data refinement, some adjustment and optimization, some 3 buckets. And all these 5 different characters of Bayesian versus this versus that, all fell into these 3 categories. I said, fantastic. So I started explaining this, maybe there's an idea to make a master algorithm and forget about all this, either just statistically based or this based or that based. Let's work on master algorithm, right? Then I threw this idea about how to integrate real science into data science. That's when things got heated. They said data science is real. I said, what about this biologists who are bothering me with all kinds of nonsense, this physicist, this chemist, they're writing differential equations, they're extrapolatable to some degree and all that kind of stuff. Data science is based only on the past history. How much can you really project? They started telling me the imaging. I said, doctors are fantastic. Imaging works great. I walked away with an impression that today's AI technique is pattern recognition, pattern filling. And when I said that, the guys went berserk. They threw me out of the office, saying, it's far more sophisticated than that. I said, okay. Then some 2 graduate students who were sitting back of the bench there, they came to me and said, yeah, it sounds interesting. Then the question they asked me, how much are you willing to pay? Then I said, the market rate. They said, no, this is an impossible problem you're asking to solve. I can make a lot more money in applying what already exists and Indianizing it. I said, I cannot argue with that. That makes sense, right? But somebody should be working on this. Then I forgot about this. Then this actually I wrote a paper on this and sent it to all the famous people, some of you know. And they all came back and saying, they wrote something, say, okay, if you can do it, but don't bother us. Basically, that was the conclusion. Then other day I was sitting, this is even before the DeepSeek, right? Somebody told me, hey, Nindan Nalakani is talking about we should be developing new algorithms. I said, fantastic, we should be doing it right away, right? I said, I was thinking about it 8 years ago. But I know nothing, what can I do? Then the DeepSeek came about, and then I started reading about it, said, how the hell they're solving this problem? It's very similar to what I was thinking about in 1995, that you distribute the problem. You break up this whole damn problem into multiple problems and have different areas to solve it and then bring it together with a master to control it. It makes it cheaper, makes it faster, and solves it at a much faster rate by even. That is my concept of this. I used to call it adaptive refining. I even gave a term. If I wrote a paper, or not a paper, I gave a presentation to some mathematicians about my concept of adaptive refining. I should solve these matrices only when I need them, type of thing, and break up the problem. And I made some fancy pictures. It was all conceptual and nothing real in terms of mathematics, equation, this and that. So people are all energized, right? But nobody knew how to solve it. I'll be honest with you, nobody knew how to solve it. Even I didn't know how to solve it. I'm not no mathematician, but I knew something about some mathematics here and there. I forgot about it. Until this DeepSeek thing, I said, maybe I should bring this problem back. We should have this algorithm where I can integrate data science with known science. Whether it's a physics problem, it's a chemistry problem. We write differential equations as if there's no tomorrow. No? Amal must be writing damn differential equations on a daily basis, solving them. He may be calling it Gears method or some other method or whatever the hell it is. At the end of the day, it's just nothing but Newton's method, steepest descent. Steepest descent. You may give different names to it, and the data science have their own names. And they do, they're fascinating. Don't get me wrong. The fact that they can put several thousand parameters and tune them is just mind-boggling to me, right? When I used to go beyond 5, then people are saying, are you fitting an elephant or a giraffe or something, I say, I don't understand. These guys are fitting, got millions or something. But nobody's questioning whether it's an elephant or giraffe. Everybody's happy, right? And then everybody said, actually, I heard this coined by somebody. These models are statistically relevant, okay, but may not be accurate, right? I said, fantastic, man. Statistically relevant, but not necessarily accurate. But that's what we are living with. It's okay to move you from buying A versus B. Is it good enough to solve climate change? I don't know. Maybe that's what it is. It's such a complex problem with all kinds of possibilities. That's what I need. Statistically relevant, but may not be realistic. And I witness that every day on my phone. When I start to type something, my AI system takes over and starts filling in all kinds of stuff. And then people say, what the hell did you write? I say, I don't know. AI did it. It's not me. Sorry about this. I took a long time to answer your question. But the thing I'm talking about is that AI is really very promising, right? It's going to have a lot of potential. It's not going to solve your food, climate change, or water problem. But entertainment, getting you hooked onto platforms, giving you some optimal solutions. It'll solve many practical problems on a daily basis. Imaging problem will actually be solved like that. Complex problem like climate change, would it solve? I don't know. But I hear all the time, AI is going to solve climate change, right? Only thing I know is that AI is going to require so much energy that probably everyone is going to have a nuclear reactor. That's a good thing to do. Maybe we can shut down the data centers and use that for real energy, Sorry about my language. And I'm sure I must have upset a lot of people who are listening to me, and I'll get a lot of flack about it. But at my age, I don't care. This whole thing is just to stimulate conversation, okay? Just to have an open and honest conversation. And if I'm wrong 90% of the time, that's better off because you'll have given some ideas to solve it yourself. And that's the whole reason I'm doing this, right? It's not to badmouth somebody or make a joke. That is not the case. It is to make you think and stimulate your own brain cells independent of this biologist putting electrodes on you. So maybe you can solve some real problems.
Right. Ajit, on that note, we have to stop.
No, I know.
Thank you so much for being here. Always stimulating to listen to you. And I just want to give you, on behalf of NCL, a small gift on our...
Anything? Or just that pointer?
Ajit, you have to come down.
You didn't download it, did you? Huh? If it is on your computer, please delete it. Huh? No, it's not the slides I showed. There were other 200 slides of my random presentations. I normally do I have like a stack of 250 slides. And I choose the ones depending upon what I'm talking about. And there's all kinds of stuff that you won't even understand why he's there. I mean, I don't know why he's there. He's been there for many years. But once in a while I remember it. Okay. I'm doing better, sorry.
All right, thank you. Thank you.